Wow, I was not expecting it to look like this. The pads on this compactor's roller are extremely worn. But I'm going to bring this roller back to life. It's just going to take some welding, gouging, and a bit more welding. Let's run it back to the beginning. Firstly, I need to add these wear plates onto the new 140 pads. The paint on all the pads have been grounded off, so they are prepped and ready for welding. So I kit up and got right to it. The material of the wear plates I'm adding on is Benox. Benox is suitable for this application because it has a high wear resistance. The roller is working at a road construction site. They have been doing a lot of blasting, so the terrain is very rocky. From what I have heard, the rock there is extremely hard. It's causing all the machinery on site to wear a lot faster than usual. Take a look at this bulldozer. It's working on the same road construction site. The track shoes are being replaced because the grouser bars have worn away. I'm no geologist, but I want to find out how hard this rock actually is. I felt like a caveman discovering fire when the rock sparked on impact. But besides that, you can see the rock doesn't break or even crack. All these rocks were jammed in the bulldozer's undercarriage and track guards. So they are definitely the rock doing damage at the construction site. As I mentioned, I don't know much about stone, but it looks like if those rocks were crushed, it would be the same stone they use in concrete mix. Oh, and by the way, the rock I just showed you is easily about 10 times smaller than the rock the machines are dealing with on site. Anyways, enough about rock and more about steel. These wear plates are definitely going to give the pads a lot longer lifespan. As you can imagine, a lot of penetration is needed when welding on the wear plates. So I'm going to demonstrate with a 10mm plate just how much penetration I'm getting with the welding. I'm going to weld runs back and forth until it melts through the plate. 1, 2, 3, right through. And I was not pulling my welding puddle slowly. In fact, I was pulling it faster than when I weld the wear plates. Just for interest's sake, take a guess how many meters of welding was needed to weld all the wear plates onto the caps. I'll give you a second to think about that. At this point in the repair, the roller was not yet at the workshop. I'm just getting the caps ready so when it arrives, I can complete it as quick as possible. Pulling a machine off of a construction site can cause a lot of delay. The roller is coming to the workshop on a Friday night after the construction site closes, which leaves me with just a weekend to complete the roller so it can work again on Monday when sites open. Alright, all the new caps now have wear plates. Now let's see how many meters of welding was needed. Firstly, let's work out the perimeter of one wear plate. That's 422 millimeters. Next, let's times that by 140 caps. That gives us 59,080 millimeters. Divide that by 1,000 to get meters, and we get 59.08 meters. Next video, I'm removing the old caps and welding on the new caps. Stay tuned.